In this video, we are going to do some dilation constructions. And we're going to focus on ones where we enlarge the shape that we start with. So when we do a dilation, that's a transformation where you take whatever object you started with and you end up producing another one that has the same shape, but the size depends on this factor that we call the scale factor. And we use the letter K to represent the scale factor. And the scale factor is telling you whether you're going to scale the figure up and enlarge it and make it bigger, scale it down, make it smaller, don't scale it at all. That is determined by this number. Let's think about what numbers would produce various results. If we want to get our new length, we're going to take our old length and we're going to multiply it by the scale factor. So if I started out with a scale factor that was, let's say, 1, I would take my old length, I'd multiply it by the number 1, and the new length would give me back the exact same number that I started with. And so if your scale factor is 1, you preserve the size. You don't change the size of the shape at all. Nothing happens. It doesn't get bigger, it doesn't get smaller, it stays exactly the same. The other number we might want to consider as an anchor point is what happens if the scale factor is 0. So if I have my original old length and I multiply it by the number 0, anything times 0 is going to give me 0. So whatever the old length is, if I scale it by a factor of 0, my new length is going to be 0 and my shape disappears. So it vanishes, it goes away into nothing, shrinks down into nothing. In between 0 and 1, you have all these numbers. All the numbers between 0 and 1. Half, a quarter, a third, decimals like 0.8. Lots of numbers that are going to make your new length end up smaller than your old length. Because let's say my old length was 10 and my scale factor was a half. I do 10 times a half and my new length would be 5. And so when your scale factor is somewhere between 0 and 1, you shrink your shape. If your scale factor is more than 1, like a scale factor could be 3, could be 2.5, could be 10, could be 1.8, any number that's bigger than 1, you're going to take your old length, multiply it by a number that's bigger than 1, and of course that's going to make the number get bigger, and so your new length is going to be more, and you will have enlarged the shape. How you actually construct a dilation works like this. You start out with a shape. We're going to use triangles because they're the most basic polygon. We're going to start out with this triangle A, B, C. And I'm going to dilate from point B. And I'm going to do a couple different dilations. The first one is going to be a scale factor of 2. If my scale factor is 2 and I'm dilating from point B, I need to go to point B and all the distances from B to any other point on the shape, they need to get scaled up by a factor of 2. So whatever the distance is from B to A, I need to take that distance and double it. So however long this is, I'm going to put another one of them over here, and that's where A prime is going to be. However far it is from B to C, I need to double that because my scale factor is 2. So I go from B to C, and then I would double that, and I'd get to C prime, connect A prime to C prime, and now I have my old triangle, this one, triangle A prime, and I guess we should say what happens to B prime. If B gets dilated from point B, there's no distance. B is on top of itself. And so when you double nothing, you still have nothing. There's no distance between B and itself. So if I was to scale it by a factor of 2, it doesn't go anywhere. It just stays there. So this is also B prime. triangle A prime, B prime, C prime is our new. If instead of a scale factor of 2, I'd used a scale factor of 3, we would just, instead of doubling, we would triple. So however long this is, the new one needs to be 1, 2, 3. 3 times as long. So this is where A double prime would be. This one is triangle ABC prime. This one will be triangle ABC double prime. To go from B to C, if I wanted to use a scale factor of 3, I would double it, triple it. 1, 2, 3. This is where C double prime would be. And now I have my old shape, I have my new shape scaled by a factor of 2, I have another new shape over here, well, same shape but new size, which has been scaled by a factor of 3. This is what happens if the point you're dilating from is on the shape, but if the point you're dilating from is off the shape, that's fine too, that can happen. Like I could start with the same triangle A, B, C, and let's call this point P, and I want to dilate by scale factor K equals 2. Just like we did over here, when you dilate with a scale factor of 2, you take whatever distances you have from the center of dilation and you double them. There is some distance from point A to point P. I need to measure that distance and then I'm going to double it. And A prime will get pushed away out there, because when your scale factor is 2, you should expect to enlarge your shape. To go from P to C is some distance. When I scale it by a factor of 2, I double it. And it gets pushed out here. To go from P to B is some distance, and when I scale it by a factor of 2, I double it, and it gets pushed out to somewhere around there. And then I can connect these to produce my dilated shape, which had a scale factor of 2. Let's actually do these constructions. I'm going to do, maybe I'll do one of each. The stuff we drew previously, that definitely belongs in your notes. This part, you could follow along and sketch it if you like. If you have a compass and a straight edge, of course, do it along with me. Otherwise, you can just watch and be ready to do this in class. Here is some triangle. A, B, C. And I'm going to dilate from point A. Sometimes, well, actually very often you'll say centered at point A. You'll say dilation centered at point A, and I'm going to use a scale factor of 3. I know that my distance from A to B needs to get doubled, tripled. Whatever this distance is, it's going to get pushed out by a factor of 3. And so the new points are going to lie somewhere on a line segment that comes from extending this existing one. So I'm just going to extend this line segment out, because I know that the new point, B prime, is going to lie somewhere on this. And I know that when A pushes C away, the result is going to be somewhere along a line segment that you get from extending AC. And now I just need to triple everything, triple every distance. The distance from A to B, I'm going to measure what it is. I'm going to check my measurement. Yep, that looks perfect. And now I'm going to extend. So if I make one copy of it, that would be doubling it. If I make a second copy of it, that would be tripling it. This is where B prime lives. To go from A to C is some distance that I can measure with the compass. And I check to make sure I set this right. Yep, perfect. And now if I had a scale factor of 2, I would make one copy, because I'd be doubling. But I have a scale factor of 3, I need to triple. Uh-oh, barely gonna make it. Just on the edge of the page. And let me extend this a little bit. There we go, just barely made it. So that is where C prime lives. And now to complete this, I need to connect these points. Right here, A, B, C is your original triangle, and then here, A prime, B prime, C prime is your dilated triangle with a scale factor of 3. Let's also do one where we dilate from a point that is not on the triangle. I'll make, put it down here. So I'll start with some triangle. Let's call it A, B, C. And I want to do a dilation centered at P, and I'm going to use a scale factor of 2. And let's say P happens to be located right there. That's where point P is. So whatever distance there is from A to P, I need to double it. From B to P, I need to double it. From C to P, I need to double it. I only need to pay attention to those 3 points, because if I can figure out where those 3 points are, then I can make the triangle. In reality, a dilation extends out or shrinks in every single point. Like there's a point right here that's getting pushed out by a scale factor of 2. But this point is not that helpful in the creation of the triangle, because it's just some random point along the side, and it's not really helpful for me to redraw the triangle. The points I need in order to redraw the new triangle are the vertices, this one, and this one. So those are the ones I'm going to pay attention to. I know that when I dilate point A, the result needs to lie somewhere on the line or the line segment that connects A to P. I know the same is true for B, so I'm going to draw this in. And the same is true for C, so I'm going to draw this in. If I have a scale factor of 2, my distance from P to A, I need to double it. So I'm going to measure how far it is from P to A. That looks pretty good. And now, if I make one copy of it, I will have doubled that distance. I'm going to measure how far it is from P to B. About there. And since my scale factor is 2, I need to double this. So I'm going to put one copy of it here. And you see how I did not extend this far enough? Don't sketch it in by hand. Take your straight edge, put the straight edge back on that line segment, and extend it so that your construction is precise and perfect. B prime goes there. Last one I'm going to measure from P to C. Goes there. I'm going to double it. Here's C prime. And now I can connect everything. I want to connect A prime, B prime, and C prime because these are the dilated vertices. And if I know where the vertices are, then I can draw in the triangle. Last one. Done. Original, dilated by a scale factor of 2. If you wanted to check yourself, you could get a ruler and measure some stuff. Let's use this side. This looks to be, maybe this one. Yeah, there we go. Nice one to measure. This looks like it's about 4 centimeters. So I'm hoping this one's going to be 8 centimeters. If it is, then I know I did the construction right. And yes, 8 centimeters. This was a good construction. I doubled things, doubled lengths.